Let me start this by saying that if anyone wants to do YouTube as a career, think again. Video editing is a nightmare. So I've got isopropyl alcohol. I use this usually to start the burn. Easy to ignite, burns clean, yada yada. Click on the air here. It's gonna flame out because there's too much air, not enough fuel. Wait for it, wait for it. Yep, there we go, flame out. Reset. I have a cotton ball soaked with oil and isopropyl alcohol. This should allow it to sort of vaporize the oil and burn for at least a little bit longer before it starts to destroy the wick. I've got it in a propane cylinder that I cut pretty much in half, clicking on the airflow here. It starts to burn pretty well. There's a little bit of smoke. Now, watch this here. In a moment, I kick up the airflow, and all of the smoke immediately clears. Look at that. Fantastic. So, we know for sure that it needs plenty of air. Just an abundance of air. You can't have too much air. As long as it's not flaming out, you can't really have too much air. So, in the next clip, I start up my rapid response CO detector just for some testing. I have a high quality CO detector in the garage just for safety purposes. Do not mess around with this. If you're burning waste oil, do it outside or have plenty of ventilation and absolutely have a good quality CO detector. It will sneak up on you. There's a reason they call it the silent killer. Seriously. Anyway, doing more testing. It's burning very clean. At some point, it will detect a reading. It's not the best. It needs to be done outdoors or ventilated. With less airflow, the meter is able to detect a reading a lot more readily. Also, without air, it's smoking. So, take that for what it's worth. I mean, I'm just basically at this point just making sure that my detector is kept. I kick on the airflow, it starts burning pretty well, and we're gonna find a catastrophic failure. You see about 20 parts per million at the exhaust, more or less. The detector might not be getting a pure reading. Could be 120 parts per million. Could be 240. I don't know. And the motor separated and failed. So that was not good. What I have for you here is here's the motor. I attached it with hot glue. Now, excuse me. Hot glue obviously is not ideal. This assembly was nowhere near any source of heat. Any heat that would have melted or weakened the hot melt would have been generated by the motor itself, which is very possible. It's moving a lot of power. I could try again by wrapping the hot glue around the casing with sort of fingers, if that makes any sense. I think that would work. Actually, I'm almost certain it would. But instead, I'm going to use an epoxy or polyurethane probably to seal this ring here. I've been thinking about making two separate outlets, one smaller, one bigger, to have a burn feed and a airflow over a heat exchanger. That's for a future project. Right now, I'm just trying to. Ultimately, I'm trying to make a water heater, but this is just some testing. So we'll see what comes of that. Some more pictures here. This is it burning, more burning. The highest reading that I recorded after a flame out. I actually put a torch to the smoke, and the smoke ignited. So that was, and that was filling the garage. So I had the overhead door open, had my shirt over my nose, crunched over, evacuate, make sure that the flame is gone, and then get out of there. GTFO. There was 17 parts per million when it's burning. Good. I thought I had some more images, but eventually, I checked the temperature of the housing. It wasn't particularly hot. I only ran it for a few minutes. Yep, that's about it. This is probably one of the longer clips-ish. Hit that like button if you wouldn't mind, just for the algorithm. I know my quality is not top notch, but I'm just messing around. Hopefully you get some inspiration from this. Cheers. Thanks for watching. See you next time.